who have recently joined, let me point you in the right direction. So the way the revision hackathons go is we are going to repeat the actual lecture done by the primary faculty, right? A very good noon, Ravindra sir. Yeah. So I'm going to point you in the right direction. So let me go ahead and share my screen. Yeah. I hope my audio is clear. If my audio is clear, type A in chat box. Great. Yeah, so people who are watching us on our social channels, you can use the chat or comment section to interact with us. Great. So this is how your Teachable looks like. And here, now we have covered previously all these lectures. We started from module 1, completed our hashing, module 4, where we have understood the, how the Bitcoin wallet address is created and a little more details about the transactions. In module 5, we have understood transaction inputs and outputs and how each of the script operations are executed, right? So we've understood all of that. Now we are going into the module 6, right? So where in our previous sessions, we have yesterday's session also, we have covered a little, on Tuesday's session, we have covered a little, and today we are going to continue from there, right? So people who have joined us recently, you need not worry, right? So you can go ahead and begin from lecture 0 and reach to the point where the hackathon is going on, and the hackathons will happen in a cyclic fashion, right? So once we finish 10 and the solidity, then we'll start from the beginning, right? So other faculty members will start from the beginning. So you need not, worry that you're not able to catch up. So I would request you to go ahead and start from the primary lecture if you have recently joined. So there are others also who are actually starting from beginning and also joining hackathon. That is also fine. You can parallelly complete into two lines, and then you'll have a clear picture. So as you're catching up, you're also aware about the 4th and 5th modules, or that way also, right? So it is completely up to your choice, right? So yeah, so how many of you have recently joined, like in the past month? If you've joined in the past month, type me in the chat box. Thanks, Prashant. Thanks, Vijay. Okay. Thank you, Sharayu. Thank you, Sagar. Okay, great. So don't worry. So I'm going to, also, make it beginner friendly if you are planning on to attending the whole hackathon also, right? So many people have asked where are the recordings of the previous hackathons. You can go into the inner circle, right? So let me share the inner circle. In inner circle, towards the end, you'll be able to find all of these sessions also. I'm sharing my screen. Yeah. So now if you see the inner circles, it will have all the, all the other sessions also. Now you can see that there is blockchain revision hackathons, and you can go through these sessions as well, right? So you can go to the actual lecture and parallel revision to the same. There is more, right? Similarly, you can go revise both of them, like complete the actual lecture and revise it, complete and revise. So your recall of concepts is stronger, right? So I hope this is clear, and if the people who are joining now also, it will be helpful, right? So let us actually revise what we have understood in our previous session, right? So in our previous session, we have understood a few concepts on what is public pay to public key hash, where you're sending it to one person, and a few disadvantages of it, right? So I hope, Ravindra sir, if you missed previous sessions, we were covering the module 6, the initial portions of it, where we have understood there are a few limitations when you're trying to send money to Bitcoin to a person, right? So what happens if the person is no more, or somebody, the key is stolen, right? So in those cases, there is other way of using sending the signature, which is the multi-signature, which is pay to script hash, right? So we've also understood that. The session will also be there in the inner circle. If you've missed, you can go ahead and see, right? So what happens in multi-signature is, if, for example, there are 3 people who can access the funds, we can specify that 2 out of those people, 3 out of those people can, if their signatures are available, this will be a valid transaction. So what happens here is M out of N signature scheme, right? So for example, out of 10, if there is 3 people signature in the public key, you can specify that, right? So how do you do that? You do this in this particular fashion. You say 2 out of 3 or 5 out of 10, right? So the maximum could be till 15, and then like how we have OPD, UP kind of operations, there we have an operation in script language, which is OP check multisig, right? So it will check if there are 2 signatures out of 3, you can go ahead and verify that particular transaction, right? So what happens is, if the key of one person is compromised, you'll be able to, B or C will still be able to access that funds. The money is not lost, because in Bitcoin system, there is a scarcity of funds. And if you make a mistake while sending it to someone, and if the money is lost, and it is lost forever, right? So for that reason, this multi-signature concept comes handy, right? So if you understood this, type U in the chat box. If you missed previous session, you can go ahead, watch it from the inner circle, right? So if you understood this, type U in the chat box. Thank you so much, Rajesh. Okay, so yeah, thank you, Sagar. Now what we are going to do is, we are going to pick up from where we left, right? Okay, so we have seen the advantages of multi-signature in our previous session. To also understand the technicalities of what are there in input and output, right? So if you remember, like people who have joined us in our initial sessions in our hackathon 4, we have spoken about the structure of a transaction, right? The structure of a transaction is this way. There's a version number, there is an input counter, the inputs are also there, the output counter is there, outputs, and lock timestamp. So what we have told is, like, we'll talk about the lock timestamp later. So today is that day. So we'll talk about end lock time, and we'll also understand the structure of this in a deeper level. So we know that any transaction that, like, for example, in this case, Tom is sending some Bitcoin to Alice. The version number is specified, the how many inputs. For example, if Tom is sending 3 Bitcoin, then 2 inputs are being clubbed here. So the input counter will be 2, right? So the input value will be 3 Bitcoin, because if he's planning on to send 3 Bitcoin, the output will be, let's say, 1 clubbed, 1 output is going, right? Because you're only sending to Alice. If you're sending to other multiple people, because a transaction can have multiple people, so you can have multiple outputs also. And there is an end lock time. So we'll also discuss about that. So to understand further, we'll understand the size, like how much memory each of this particular element takes, right? So now this is what we have understood. This is a version. There's an input counter, the inputs, the output counter, outputs, and the lock time, right? Any transaction, like whenever you do a transaction, there's a transaction ID in a regular system that gets generated, right? So whenever a Bitcoin transaction happens, these are all the elements present in that. So the input transactions, in each transaction, there are inputs and outputs. So in inputs, we have seen in our previous session about transactions, right? We see that there is a transaction hash, there is an index, there is a script signature, right? So how many of you remember we had the signature and public key hash in the input, right? So we have also used the stack to, understand how the operation works, right? So sequence. So I'll just quickly, give you an understanding of that. I'll share the reference of the reference also here. I'm sharing it on chat. So this do not go deeper currently. I'm just going to help you go through it. For example, we are trying to assess transaction input, then we'll also assess the transaction output, right? And what kind of transaction we are looking at? It's a non-coin based transaction. So what is a coin based transaction? In a previous session, we have told coin based transaction is where a new block is getting created. There's no input coming. A new block is getting created by the miner, and he's getting a block reward for that. So there's no input. So the structure for that is different. So we'll talk about that in our next upcoming session. But a regular transaction, when you say non-coin base, it means it's a regular transaction. So now we have seen the same elements here: hash, index, script length, signature, script. So you can see here the previous output. It is going to be 36 bytes, and a few, for example, if it is this signature script, it says it varies, right? So it's based upon the signature script. For example, if the signature you are giving the direct signature, the length of it can vary, right? So based upon that, the number of bytes can also vary, right? So for that, we have a specific list of bytes and the size of it. So I'm going to show you that, right? So I'm going to put it on slide. Okay. So what I'm going to do is I'm going to show it this way only. So now when you say check the size of each element, right? In input, there is hash. The hash is roughly around 32 bytes, right? So the hash is roughly around 32 bytes. And the index of the output, which is a number which will be between 1 to 9 bytes, right? So that is also mentioned. There is a script signature length that is between 1 to 9 bytes, right? So these are a few things that professor explains in the session. So these are some numbers that are good to know, right? You do not have to remember all this, but it is good to know because I'm going to share another reference, right? Which is a little, this particular reference where all of this is also mentioned. Like, for example, version number, the size of that would be 4, right? So the in counter, the size of that would be between 1 to 9 bytes, right? Similarly, there is a size for each element, right? So witness is nothing but the PK script, right? It is variable. Okay. So similarly, whenever there is an input and output, each of the element has its own size, and that is what a standard size has been mentioned here, right? So n sequence has it takes 4 bytes. Similarly for output, whenever there's the output, there's a value, there's a script length, output value. So how much amount of Bitcoin you're trying to send, right? What is the length of the script? What is the actual PK script, right? So all of that size is mentioned here, right? I know that professor takes a lot of time to mention all of these sizes, but basically these are numbers that you might want to remember or understand. There is the size of each of these elements are also mentioned. So whenever you want to get through that, you can always go and navigate there, right? So I'm going to show you this is what professor also explains within the lecture. So if at all you want to understand or make notes directly from the lecture, you can go ahead and make understand the size of each of these bytes. So here professor is explaining there's a transaction happening, and each of the elements is explaining on how much size it takes, right? So that is the reason I've just mentioned all of these sizes here in a single slide, so it becomes easier to understand, right? So to also understand the structure of a transaction, So what you will understand is each of the element is going to take some size, and that size is mentioned here. Okay, Sagar. So basically, you will find these in the inner circle only, in the inner circle. I think I understand your point, because there the notes are more or less, writings, and you'll not be able to go through it or reference it. So I'm going to put up these presentations also in the inner circle only. So you'll be able to find it there. Yeah, thanks for that. Okay. Yeah. So now, so we've understood each one of has the sizes. Because this is numbers, we're not going to spend much time on it, right? So if you've understood that each of the element has a size, and that size is also mentioned in all the references. If you understood that, type U in the chat box. Thanks, Sagar. Thanks, Lakshmi. Thanks, Vijay. Thanks, Sridhar sir. Right. So now, basically, in one of the references, this has been mentioned in a visual format also. But visuals should actually make it easier to understand. But if you spend some time, even you can try to understand the same. So what they have done is, they have listed down a transaction. So this is, let's say, one transaction. And there's another transaction. For example, there's one transaction which has multiple inputs and multiple outputs. So they have tried mentioning it here. So the version is taking 4 bytes, and the transaction ID is listed out here. Each transaction, all the bytes have been mentioned here. Like if you see the value, they have mentioned it as 8, right? So you might want to go through it, but it's based upon your own discretion. Yeah, so this is the concept behind it. So here in this diagram, the challenge is they have also mentioned the coin-based transaction. So because which we have not discussed. So I would request you to, if you're going through the reference, go through the general format of a Bitcoin transaction, right? So these will be more relevant for you. The numbers will be congruent to what professor explains in the lecture. Okay. So now we've understood each of them is having a size. Now, what is the lock time, right? So we'll try to understand this, and we'll spend more time on lock time because that is more conceptual, right? So now, basically, so let's try to revise how the transaction happens, right? So I'm going to just put out a sheet here to just explain. So for example, whenever you have made a transaction, whenever a Bitcoin transaction is put out, it goes into the memory pool, right? It has multiple names. We are calling it memory pool, right? So now this has not been validated yet, right, by any miner, right? So now say I'm going to say Bitcoin, let's say Bitcoin transaction 1. Okay, so this first transaction that happened, right? So now what happens is, whenever one transaction happens, because many people are doing transactions, all transactions get appended or added towards the end of the other transaction. So there is, let's say there is a second transaction that happened, right? So in the first transaction, whenever the second transaction happens, that means this one first transaction was confirmed once, right? So what happens is, after the actual transaction, how many ever new blocks get added, every time the verification of the previous blocks happens, right? So for example, we are going to say there are 6 transactions that happen, right? And I'm going to kind of make it easy here. So there are 6 transactions that happen. Now, this transaction will have something called 6 confirmations. Okay. And similarly, there will be 5 confirmations here. Okay, so let me just see if this works. Okay, now you can see that each of these transactions, so this particular transaction has 6 confirmations, right? So how do we know what are confirmations? Basically, let's say I'm going to go to our blockchain explorer. We have seen how to explore in the blockchain. So people who have joined recently in our previous hackathons, we have explained about it, right? So I'm just going to help you understand. So now whenever you open a block, any transaction in that, so there is something called confirmations that will be mentioned there, right? Yeah, so this transaction has say 2,77,944 confirmations, which means, right, so it's also the depth over that, like, from the current transaction, the depth of it is that, like, there are so many other blocks that got added over that, right? So, or those many number of times the transaction got confirmed, right? So this is how this happens. Like, for example, a standard, for example, in the memory pool that one particular transaction went and it is not validated, there is a chance that it will be sent back, and no miner is going to put it in a block, right? So if any particular blockchain transaction is minimum verified by 6 people or 6 miners or 6 times, then you can consider it as a transaction that will not be sent back, right? So basically 6 is a number. When you're talking about confirmations, you can be sure that your transaction is now not going to be rejected, right? So this particular process of confirming a transaction 6 times roughly in a standard case takes 1 hour, right? I'm going to say roughly 1 hour. Okay, and this, if you have 6 confirmations on your transaction, which means 99.9% your transaction is not going to be rejected, right? And it is going to be uploaded onto a block, right? So if this is clear, type C in the chat box. Yeah, so if this particular process got clear, type C in the chat box. Thank you so much, Sagar. Okay, so based upon this, we'll also, thank you so much, Raindra sir, right? Thank you, Sanket. So now we've understood this, right? So now what happens is, whenever you make a transaction, like, you can specify a time stamp of when you want this transaction to be available for verification, right? So basically what it is like automation, or you can specify a particular set of time. Like, for example, you made a transaction and you do not want it to be validated immediately. So what you're going to do, you're going to specify a lock time. So during that lock time, once no one will be able to validate that particular transaction, right? So basically here, I'm also going to run you through the actual end lock time definition, which will be more clear. But to simply understand, it is the time that you're specifying, right? There are 2 ways to specify. Like, let's just say you can specify in a regular scenario, specify a transaction can happen, like, after so many seconds, do this, like, say 2000 seconds, do it, or say after so many minutes and hours, do it, right? So there are 2 ways of specifying after how much time you want this block of that particular transaction to be available for verification, right? So this is the end lock time, right? So if you don't specify it, it goes immediately meaning once you upload it within 1 hour, it will go for validation. But if you do not want it to be immediately validated, you can specify an end lock time. So the concept of end lock time is that, right? So if you understood the concept of end lock time, which is you want to specify post this much time, put my transaction for validation, right? So if you understood this, type U in the chat box. Thank you, Sharai. Thank you, Ravindra sir. Okay, so that is n-log time. So now let us actually go through the definition, right? Okay, so I'll break this down and I am also going to explain each of this. I'm going to share the reference here with all of you so that later you can also go through it. So now n-log time is a parameter applied to each transaction specified either in Unix time or block height, right? So as I've told you, n-log time can be specified in two ways. So we'll understand each of these. Before which, so specified in, the transaction time is specified, before which the transaction cannot be accepted into a block, right? If all the inputs in a transaction have a n sequence, so basically this is a little technical. This is something you can put it aside, right? So basically there is a, what if this says is if all the inputs, inputs, right? All the inputs in a transaction have n sequence equal to u int underscore max. So we'll also come across that. So which means if it is happening in the current time, then n-log time is ignored, right? So if you do not want it to, you do not want to specify n-log time, it will happen within 1 hour of you doing the transaction, right? So I hope till here the definition is also clear. So n-log time is a parameter applied to each transaction specified in two ways, Unix time or block height, before which the transaction cannot be accepted in a block, right? So this is the actual definition. Now let's understand two different ways we are talking about, right? So which will require us to understand this, right? What are the two different ways, right? So one way is, let me format this. Okay, two ways. First way is this: if the n-log time, right? So n-log time is going to be a integer, right? It's going to be a number. You're going to specify. You are not going to say 9 a.m. Saturday 2023 February or something like that. So you're going to give it a number, right? So if the number is less than 5 to the power of 8, meaning 5 and 8 zeros. If n-log time is less than 5 to the power of 8, the integer is interpreted as block height, after which this transaction can be accepted, right? So now what is block height? Now, if you see here in this particular transaction, for example, right now you're on, let's just say 5 lakh block, and you want this transaction to be verified at 5 lakh 50 block, right? So you will, I'm just giving you an example. It's an hypothetical example. So if you represent it in integer, which is less than, because n-log time is if it is less than 5 to the power of 5 into 10 to the power of 8. Now 5 lakh 50 is less than this particular number, and it will consider it as a block height, right? So what the miner or the node will do is it will check n-log time number that you have specified. It will see if you have specified it or not. If you have not specified, what is going to do? Okay, I'll wait for 6 confirmations, and then it is going to confirm it within 1 hour. If it is less than 5 into 10 to the power of 8, it is going to see, okay, this person wants this transaction to be verified after so many blocks, right? So then before that I'll not be able to verify, so let me be it in the memory pool. If it is otherwise, meaning if it is higher than 5 into 10 to the power of 8, then it is a timestamp, right? So now this timestamp is called a Unix timestamp. Most of you might be aware if you are if you've heard about it, right? So how many of you are aware about Unix timestamp? Type me in the chat box. Correct. It is the logic of waiting time, right? Sagar. Yes, thank you so much, sir. Now, for the people who have recently joined or people who do not understand the Unix timestamp, I'm going to share another reference, right? So let me also explain this, right? So in computer language, whenever, like, each movement, like for example, each passing second here, you see, is getting added to this particular number. So now if you see this particular number, it is going to, I'm going to refresh this, right? So now this particular timestamp means the year is 2023. It is so and so month, so and so day, and it is in UTC, right? So if it is GMT, based upon in GMT, so and so many hours, so and so many minutes, and so many seconds, right? So this is how this is converted or understood by any computer program or any other language, right? So Unix timestamp or epoch time is nothing but from one particular timestamp, which is 0, every second is going to get specify one particular timestamp, right? So if we try to understand, right, so what is the epoch time? I don't know if I'm pronouncing it right. So since January 1, 1970, right, midnight, meaning 12 o'clock, 000, since then, every second is one timestamp. And from that point, we have moved in so many seconds currently, right? So that was 00, all zeros. And today, after 1970, we are so many seconds in the future, right? So if you have understood, people who have not understood the Unix timestamp, if you understood it, type U in the chat box. Yes, thank you so much, Sagar sir. Right, so this is how now you can see that this is definitely greater than 5 into 10 to the power of 8. Thank you so much, Ashish. Thank you, Sharayo. Right, so if it is lesser, it is considered as block height, right? After verification of 5 lakh 50 blocks or 6 lakh blocks, verify my block. You can specify if it is the number is smaller than 5 into 10 to the power 8, it will consider it as block height. If it is higher, it will consider it as the Unix time, right? So now let me come back here, right? So for example, I'm also going to show you, there's another reference, I'm going to share it here to make it just clear, right? Now log time. So how this is happening, if it is less than 5 into 10 to the power 8, unlocked at one specific block height. If it is greater than or equal to, it is unlocked at a specific time, which is the Unix time, right? Now, if we see, right, so they have mentioned it like, if it is less, then it comes to a specific block, or if it is, so based upon this logic, if it is greater, it will come at that particular timestamp, right? So for example, if this is the decimal, right? So if it is specified, which is less than 5 into 10 to the power 8, which is 4,52,845. What is happening here? We are indirectly telling the miner or the node, the transaction could only be relayed onto the network after the block reached a height of 4,52,845, right? If it is higher, if it's a number like this, like let's just say 14, like this bigger number, this is Friday 12th May 2017 and so time, then only go and open up my transaction, relay it onto the network, right? So similarly, if it is any other number, it's a Unix timestamp, right? So I hope this concept of n-log time is clear with the example, right? So n-log time is the parameter which specifies post what time you want the block to be relayed onto the network, and if it is less than 5 into 10 to the power 8, it means unlock at a block height. If it is greater, unlock at a Unix timestamp. If you understood this, type U in the chat box. Yeah, so professor also goes into the lecture. He explains the logic of it. That means that after 5 into 10 to the power of height of BTC, all timestamp will be unique. Yes, Sagar sir, I think we can definitely infer that. Hey, thanks for that insight. Yeah, I've also not thought in that particular ideology. I think that's clear. Thank you so much, Ravindra sir. Great. So now we've understood n-log time, and we've understood. Thank you, Sharaya. Right. So we've understood the also how a transaction is broken down, right? So as I've mentioned in our previous session, we are going to break this bigger topic into smaller topics, and the hackathon sessions will be smaller, right? So we're going to take step-by-step progress into this. So we're going to conclude this particular lecture, because the other concepts, which will be relative block time, or even, let's say, we're going to talk about the coin-based transaction, right? So all of those transactions we're going to talk in our upcoming session, right? So I hope this session was valuable and helpful for you. If you have any questions, you can put it up here on the chat. Yeah, so basically, Ravindra sir, so yeah, so the question is when or why to use n block time. It depends upon the application. So even let's just say if you're creating a smart contract, this question was actually also answered by Professor in a simple way. Like if, for example, you're creating a smart contract and you want that contract to be executed after one particular specific time, right? Or you want the logic of it to get relayed after one specific time, then you might want to use an n block time there, right? So that is one particular example. Yes, Sagar sir, consider it as a post-dated check. Correct. Yes. So depends. Like, for example, maybe Sagar sir, going by your example, let's say you are doing a transaction with a merchant, and he says, the work will be done after so and so much time exactly. And you say then, okay, so I am giving it to you, and this is the time stamp. After that only it will be validated, right? So now you'll have the flexibility, until that particular time, that it will not be there, and maybe there might be more logic. I think I'll also contemplate or understand and come back on the same, right? More wise on why we use n block time. Thank you so much. Yeah, so Sagar sir, you can relay all the emails to Jay at Pixeltests. So there's a system where emails reach to the relevant, have given the email ID, relevant faculties or teammates or exact teams, right? So based upon your subject line, you can, the mails get relayed. So I would request you to go and use the same email ID. Great. Okay, thank you so much, everyone. I request you to go ahead and revise all the concepts so that the things become more and more clear also, right? Okay, great. So let me check our social channels. Yeah, so all clear. Everybody understood. Thank you so much, everyone. So in our upcoming session, we are going to learn more about the coin-based transactions also, right? Yeah. Thanks, everyone. Yeah, this will be available on the Inner Circle Vault as well, right? So I've shown you, right? So more of all the sessions will be uploaded along with the presentations. Okay. Thanks, everyone. See you in the upcoming Tuesday session. Great. So I request you to, in the meanwhile, go ahead and finish the quiz portions. And I request you to also, because the whole idea of hackathons is to help you, progress further on yourself. Maybe from where I left, you can go ahead and start watching the lecture and finish it on your own self as well, right? So I'd encourage you to go through the lecture and also the quiz. Okay. Thanks, everyone.